Hello, everyone. Welcome to another K6 Office Hours. I'm Nicole van der Hoeven. I'm with my colleague, Paul Balogh, as usual. And today we have another guest who's also from Grafana Labs, but not with K6. And
Hey.
welcome, everybody, to Marco Pracucci. Yay!
Thank you, thank you. Hello, everyone.
Could you introduce yourself? What do you
Yeah,
do?
definitely. Yeah, hello, everyone. I'm Marco. I'm a software engineer at Grafana Labs. I'm in the Mimir team, which is the team working on our new open source project called Grafana Mimir, which is a distributed time series database. I guess we will have the opportunity to talk more about Mimir in the next few minutes. I joined the company 2.5 years ago. I love working
Wow.
here. I'm super excited about the K6 acquisition. Yeah, and I'm very happy to be here
So
with you.
you're actually the one that's been around the longest out of the three of us.
Yeah, I think I've been the employee number 110. Yeah, I remember
Wow.
that. Yeah, I remember at that time, when I joined, everything was new for me, right? And a colleague approached me and told me, "Hey, Marco, no worries. When we will double, you will be, the whole guy." And now we are 7 times bigger. So I'm very old, apparently.
Yeah. No, that is awesome. And you weren't hired originally for Mimir. You were working on Cortex, is that right?
Yeah, that's right. I worked on Cortex since day zero. I've been Cortex maintainer for a couple of years. Now, since the last 6-8 months, my focus shifted to Mimir. I'm a Mimir maintainer now. The latest news is that yesterday I stepped back from Cortex maintainership because unfortunately I don't have any spare time to work on Cortex anymore. Despite I definitely love the community around the project.
Yeah, I guess that was to be expected, right? Like
Right.
it's a full-time job.
Yeah, being a Mimir maintainer or the maintainer of any pretty complex or large open source project is a full-time job. It's very difficult, to split yourself between multiple projects.
Yeah, so can you actually talk a bit about that? Who maintains Mimir or Cortex if you'd like as well? And how big is that team?
Yeah, sure. So let's start from Mimir. Mimir has been just open sourced a month ago, nearly a month ago. And it's backed by Grafana Labs. So practically Grafana Labs is funding the project. There's a team of around 20 people around the project. And we currently have about 10 maintainers.
Nice.
That's really awesome. I think that's one of the coolest things about Grafana, that it's not, they don't just say that they're into open source, right? Like they're hiring. I think we still are constantly hiring, it seems, for a lot of people, but we pay people to maintain these open source projects.
Yeah.
If Paul is
Is-
on the ball today,
oh
yes, we
yeah,
are
yeah. I
hiring.
was I was waiting for it. I've heard the rumor that we are hiring, so it's
Yeah, we do this every week, Marco,
yeah.
just so you know.
Yeah, yeah, but there's a sort of competition because Grafana Labs is hiring as well. And we
Yeah,
have a
yeah,
dedicated
but you know,
careers page.
forget about that.
So
No.
we are the
Yeah,
same
yeah.
company, but not. But yeah, we are
I guess
hiring
it
as
Yeah.
comes
well.
yeah, it comes down to a color preference, I guess. Do you like purple or do you like orange?
Yeah, I like both. We could split the screen.
Yeah. I mean, in the end, it's all the same, and we all want to be working with cool people.
Yeah,
But
definitely.
Exactly.
so it's a team of 20 maintainers for Cortex, for Mimir, sorry.
Yeah, it's currently a team of 20 people working on Mimir or around Mimir, including a team operating Mimir at Grafana Cloud. And a subset of these people is the group composed group of Mimir maintainers. I mentioned running Mimir at Grafana Labs because Mimir also powers Grafana Cloud, hosted metrics in Grafana Cloud, which is our hosted storage for Prometheus metrics.
Yeah, I was going to ask, how long has Mimir, obviously not with the name being out in public, but how long has Mimir actually been driving or providing the metrics for Grafana Enterprise?
Yeah, right. It's running in production at Grafana Labs since about 9 months.
Okay.
So well before the public open source launch.
Yeah, so you can say it's battle hardened or tested. So.
Yeah, exactly. That's probably one of the unique features or characteristics of Mimir. When we launched it, it was not new code, never run in production, never battle tested. It was running at a fairly big scale at Grafana Labs since almost a year.
Yeah. I mean, did it start as a fork of Cortex, or was it a complete rewrite?
No, it was not a complete rewrite. It started as a fork of Cortex. In this fork, we also changed the license. Cortex is Apache 2 licensed. Mimir is AGPL 3 licensed. And for us, it was the opportunity to open source some previously closed source features we had in GEM, which is Grafana Enterprise Metrics. So what's GEM in this stack of software? Mimir is the open source time series database. On top of Mimir, we have actually built some closed source features targeting enterprise companies like fine-grained authentication. And this closed source project or product is packaged into a software called Grafana Enterprise Metrics, which is just built on top of Mimir. So Mimir is the open source one, GEM or Grafana Enterprise Metrics is the closed source one, targeting typically enterprise use cases.
Okay, we have a question here about different products. What's the difference between Mimir and Prometheus, and for that, Tempo and Loki?
Yeah, that's a great question.
That's a good idea. Maybe we should start with what Prometheus is.
Yeah, definitely. So Prometheus is a metrics-based monitoring system. It's a great piece of software. It's very easy to install and configure. It's a single server, so it's a single application you install on a machine. It's a monitoring system, a pool-based monitoring system, which basically means you configure Prometheus to discover applications and machines on the network. And Prometheus scrape the metrics from the monitored targets, like for example from your applications or agents running on the machines, and then store all these metrics, all this time series database on the local disk, and offers you a query language, which is called the PromQL, to query back these metrics. And then you can use Grafana to visualize your metrics, build beautiful dashboards, and so on. What's Mimir? Mimir is a distributed time series database for Prometheus. Basically, Mimir allows you to overcome some challenges we have seen running Prometheus. I will cover this in a few seconds. What's important to understand is that Mimir does not replace Prometheus. You keep Prometheus running in your infrastructure, and then you configure Prometheus to remote write all the metrics it scrapes to Mimir, which is a centralized cluster. And then, instead of querying directly Prometheus, you query Mimir, leveraging on some Mimir features, like Mimir offers high availability or horizontal scalability or query acceleration and so on. If you want, I can also show you a few slides to better understand the main challenges
Sure.
our customer typically see running Prometheus and how we solve them with Mimir.
That's good. So I guess with Prometheus, that's you mentioned it's scraping.
Yeah.
So it external would come in and I guess scrape the Prometheus endpoints to pull the metrics data, and then with Mimir, it's I guess we're pushing into that database for that.
Exactly.
With the remote, right? Okay.
So
would you like a
Marco,
2-3 minutes presentation?
Sure, but I also
how
have
Mimir
a question.
Prometheus fit? Mm-hmm.
Yeah, so I have not tried Mimir, so please correct me if I am wrong. But this is how I'm understanding it. I know that Prometheus already includes a time series database, and that is very good for smaller amounts of metrics and just load in general. But the reason that there are so many of these alternatives for scalable backends to Prometheus is that there's some things that Prometheus is not good at or was not really built for. And one of them is like long-term storage. And the other one is in itself, it's not multi-tenant or highly scalable or reliable. So am I correct that that is the main thing that's being addressed by these backends for Prometheus?
Yeah, definitely. Absolutely.
Okay.
Could you share my screen? I just want to show you a couple of slides.
Right.
Yeah, so we typically see 4 main issues running Prometheus, or that's are the main challenges our customers have. First of all, one of the most common use cases is having a global view across multiple Prometheus servers. Now, the recommended way to run Prometheus is to keep it close to the monitored target. So the typical scenario is that you run a Prometheus server in each Kubernetes cluster or cloud region or data center where your infrastructure is deployed. And then you want an effective way to run any query on all the Prometheus server metrics. Now, Prometheus actually has been designed to allow global aggregation across multiple servers with a feature called federation, which works well, but in our experience, it doesn't match how most companies prefer to operate. Another one is answering the question, well, what happens when my single Prometheus server is restarted or goes out of memory or for any reason is unavailable for a period of time? If you don't have a highly available setup, you will experience gaps in your metrics, which effectively means you have a blind spot in your observability. Because if Prometheus is not running, it's not able to scrape the metrics. And so during the entire period Prometheus is not running, you have no idea what's happening in your infrastructure. We also see, as you mentioned, an increasing need to isolate metrics between different tenants, especially in large companies. For example, your company has multiple teams deploying application in a shared Kubernetes cluster. How can you isolate the metrics by team so that the team A can only query their own metrics? And maybe you want a sysadmin or operation teams with the privileges to query the metrics from all the teams. Last but not the least, scalability and performance. We see companies with tens to hundred millions of metrics, and they need a scalable, reliable, and performance solution to store such very large amount of metrics. And then you want to run your high cardinality queries faster, and as you mentioned, have a long retention period for your metrics. As an example, in Grafana Cloud, we run Mimir with a retention of at least 1 year for any customer. The typical Prometheus setup is to run it with a retention which goes from a few weeks up to at most a couple of months. So with Mimir, we can solve those problems. And just to very briefly list the key points or the highlights of Mimir. Mimir provides high availability, horizontal scalability. It provides a built-in multi-tenancy, and the data from different tenants is also isolated in the storage. It provides a durable storage and fast query performance. Last slide. Previously, I mentioned that Mimir does not replace Prometheus, but the aim of Mimir is to extend Prometheus. So when using Mimir, you keep running Prometheus configured to scrape metrics from your applications and infrastructure, and then you configure Prometheus to remote write these metrics to Mimir. Alternatively, instead of Prometheus, you can use just an agent, like the Grafana agent or the recently launched Prometheus agent, which is a lightweight application compared to the Prometheus server, which you typically run on every machine. It scrapes the metrics from all the applications running on that specific machine and just remote write the metrics to the centralized Mimir cluster. And then, yes, you configure Grafana to query back the metrics from Mimir, leveraging on all the optimizations, caching layers, and query acceleration technique we have built in Mimir.
Now, what typical replication factor do you have for all the metrics that are coming in? I mean, for that high availability, there's multiple copies of that data. What's kind of the out of the box default that happens?
Yeah, we run with a replication factor of 3, which means every single sample is written to at least 2 replicas. So when you run with a replication factor 3, you have a quorum of 2. So the write is considered successful if we can write at least to 2 out of 3 replicas.
Oh, cool. Yeah, and then some questions have been coming in a little bit about folks wanting to see comparisons and results of performance. Comparing against to things like InfluxDB or or to Datadog, things like that.
Mm-hmm.
Do we have that kind of dirt to throw around and say that we're better? No.
We don't have. We don't
So
have.
here's what. Sorry, so I just wanted to read out this question from Maximal89. Where can I see results, data, and graphs comparison, performance testing Mimir with Prometheus, InfluxDB, etc.?
We don't have comparison data with other databases. I personally never tested or at least compared or benchmarked Mimir against either the InfluxDB or Datadog, stuff like this. It's something we are very open to hear from our community. So if anyone is interested, we are very open to help you run Mimir at scale, and then you can run the benchmarks yourself. I want to mention that other than GitHub issues and GitHub discussions, another way the community is getting in touch with us is the Slack channel. At slack.grafana.com, you can join the community Slack workspace of Grafana Labs, and we have a channel called Mimir, where we try to promptly address any question there about how to configure, run Mimir, and so on.
Yeah, Rose Landroche was also asking how do Prometheus and Mimir compare to Datadog, but yeah, we do. What Marco is here to talk about is his performance testing of Mimir using K6. So we have like the Mimir and Prometheus answer, but we don't have the Datadog one yet. Also, a good question about the name. Well, this is an observation from Charlie. Hi, K6 team. Out of context, Mimir in Argentina is usually used as a joke to refer to sleep because Mimir sounds like dormir, and that word means sleep in Spanish. But why is it actually called Mimir?
Yeah, it's something the meaning of the Mimir word. It's something we have heard from people after lunch as well. So yeah, it was fun. Yeah, why it was called Mimir? The first reason is because we love memes. So can you still see my screen? Our stack
Yes, we can.
is LGTM. So Loki for logs, Grafana for graphs, Tempo for tracing, and then for metrics, we needed a name starting with ham. That's
Okay.
pretty obvious, right? So we started to brainstorm, names starting with the ham letter, and we came up with Mimir, which, as far as I know, is a Scandinavian
Scandinavian.
Scandinavian name. It has something to do with gods, but yeah, don't ask me this stuff because it's not my area of experience.
Maybe we could
it's something
also
which came up
address-
internally. It wasn't proposed by me, but I was happy about the name because it was easy to pronounce even for an Italian like me.
Maybe we could also address the second part of this question by Senor Performo, Leandro. For that matter, Tempo and Loki. So I think you just mentioned, Marco, Tempo is, Loki is always marketed as like Prometheus, but for logs, and Tempo is a distributed tracing backend.
Yeah, right. So nowadays we could say that Loki is like Mimir, but for logs, and Tempo is like Mimir, but for traces.
Okay.
And the reason why I am saying is because they share pretty much the same architecture. So when I previously said, where is it? Here, Mimir is highly available, horizontally scalable. As a built-in multi-tenancy or support durable storage or offers best-in-class query performance. The same exact applies to Loki and Tempo. So they've been designed pretty much with the same architecture. Then internally, obviously, they work differently. The storage is different. One is optimized for metrics, another one for logs. The third one, Tempo for traces. But at the core, the idea is to have, highly scalable distributed databases specific for metrics, logs, and traces.
Oh, cool.
Okay, cool. That's interesting. Mimir is the new, I guess, basis for comparison, or things that are more scalable, I guess.
Yeah, so we have
So Leandro's already helping us with some research. Mimir, Norse myth figure known for his knowledge and wisdom. Actually,
Quick on the
Odin kept his
Google.
head because it had so much knowledge. Maybe he had many metrics.
Maybe.
Well, there you go. That could be a reason.
Yeah, speaking of many metrics, that's I heard something about 1 billion active series.
Yeah. Earlier last year, so nearly 6-7 months ago, we wanted to test Mimir at a fairly big scale. The main reason, so whatever we do originates from customer needs. And even in this case, we see, an increasing demand for storing very large amount of metrics, from tens to hundreds of million active series, up to even billions. We wanted to test Mimir, and we gave ourselves the goal to test it, to run it, at 1 billion active series scale, and to also meet our SLA while running it. I think it's pretty easy to run it and then have every single request or query failing, right? We want to succeed at every request while running at scale. And it was, a very interesting journey, because the first
Could you
the first
explain what
issue,
that means?
By what?
What
Sorry.
what does active time series
Active.
mean?
Yeah.
Yeah, right. So a time series is just a stream of data points. And by active time series, we mean a metric for which we received a data point at least over the last 20 minutes. So it's active if we receive the data point within the last 20 minutes. The reason why we mention it is because what typically happens is you have metrics which have a sort of lifetime. A new application, think about a Kubernetes cluster. A new pod is deployed, metrics are exported for a few hours or a few days, and then the pods get terminated for some reason, right? That's the lifetime of the metrics exported by this pod or this application replica. Now in the storage, over a long period of time, think about over 1 year, in the storage you actually have a lot of metrics. But the number of active metrics, which are the metrics which are still active right now, is typically way lower than the total number of unique metrics you have in the storage. So by 1 billion active series, we mean 1 billion unique metrics which have been exported over the last 20 minutes, not over the last 1 year, right? And that's a key differentiation when it comes to scaling a time series database, because typically any database has a very large volume of unique metrics in the storage, and it doesn't affect pretty much the system complexity or scalability. Once they've been stored, they only affect, they don't affect the write path, they only affect the read path when you query them. Right. But ingesting a billion unique metrics, active metrics, it actually requires quite a lot of resources in terms of CPU and memory and coordination between the nodes and so on. Just to give you an example, if you configure Prometheus with a scrape interval of 20 seconds, which means every metric is scraped every 20 seconds, 1 billion active metrics or active series means you are scraping an average of 50 million data points per second, which is just 1 billion divided by 20.
And also because of the redundancy that you mentioned, that there are 3 ingesters in Mimir by default, at least, it's actually 3 billion time series, active time series that are being ingested and then just made, because there are 1 million for each one that then somehow has to be aggregated back into one.
Yeah, right. So you have 1 billion metrics at the source. We replicate it 3 times, so we keep, sort of 3 billion metrics in memory or local disk, and then we deduplicate them back to that's 1 billion again.
That's pretty mind-boggling, the amount of data that, if you're retaining for a full year, and then, does Mimir do anything where over time as data metrics age out, kind of the finer granularity doesn't make sense anymore? Is there any kind of rolling up of that data to say that, okay, now instead of keeping at 20-second intervals, we roll that up into 5-minute or 15 or hourly intervals as they age out, essentially, so that by the time the year is, you maybe only have by day.
Right. So Mimir currently does not support downsampling or roll-ups.
There we go. That's a much better name, downsampling. Thank you.
Downsampling. And the main reason, it's something we will do at some point. I'm pretty sure. But the main reason is storage nowadays is very, very cheap. Mimir use AWS S3 or Google Cloud Storage or Azure Blob Storage. In our experience, the storage cost, both in terms of the storage in terms of bytes stored, and the API calls, because you typically pay per API call in S3 or Google Cloud Storage, is below the 10% of the total cost of running a Mimir cluster. So yeah, even if we shrink down the storage to zero, okay, obviously it's impossible, right? But think about, storage costs you zero. Storage will be free, whatever is the amount of terabytes or petabytes stored. You will just cut the 10% of the total cost of ownership of a Mimir cluster, which is not that impactful, right? So the main reason why you may want to do downsampling is to further improve query performances, which, yeah, definitely is something we may want to consider in the future. Right now, we are employing other techniques to speed up query, regardless, the time range, whether they are on a single day or on a year.
That's interesting.
Okay, and you said that was 50 million samples per second to get to that 1 billion active time
50,
series at the
50.
source. Yeah, 50. That's
Yeah.
amazing. So I'm even more excited to hear how you used K6 for this.
Yeah, that's drinking from a fire hose.
Yeah, that makes
Yeah.
me uneasy being on, from K6. I'm both excited and a little nervous. When did you,
Yeah.
had you already been using K6 before you joined Grafana, or how did you hear about it?
I didn't personally. I got curious about K6 when Grafana Labs acquired the company. As soon as we have been told about this acquisition, we were quite curious about the product. So we started investigating the product, but we didn't have a use case yet to run K6 at scale. Just a few months after, we have been told that we wanted to test Mimir at 1 billion series scale. So it just looked like a natural fit to use K6 for this. My personal experience with K6 was amazing. It worked way better than I expected. Don't get me wrong.
Oh, good.
The documentation was great. When you start using a product and you don't have to reach out the K6 developers anytime, because just the documentation answers you any question. Or just reading the documentation is pretty clear, the way it works, how you should write your script, how you can test your script.
That's awesome.
I loved it. Yeah, I really loved it. The only reason why we actually needed some help from K6 developers was because of the protocol required to write metrics to Mimir. So it's basically a protobuf encoded protocol on top of HTTP. It's not supported out of the box from K6. So we had to build a plugin or an extension. I think it's called extension. In
Ooh,
K6.
Yes.
can you show
Yep.
us?
Yep. Yeah.
Yeah.
So it wasn't just plain gRPC. It was a custom protobuf setup.
Yeah. Basically, no, it's not using gRPC at all. It's actually over HTTP, so it's just HTTP protocol.
Yeah.
But the content of
Protobuf.
the request body needs to be encoded with protobuf. To keep it short, to do it, we needed an extension. We got some help from K6 developers to build this extension, basically.
Awesome. Can you show us the extension as well?
Yeah, sure. I'm not an expert, but I could. So, do you want to?
This is your use case. You're the expert of your use case.
Yeah, I'm not an expert about the extension. Do you want to share my screen?
Yeah, you ready? All right.
Yeah.
Why is it not?
Oh, I think it's because
There we go.
Yeah. So I just want to mention we open sourced the K6 script with some instructions. in the Mimir repo, so under operations K6. And yeah, basically you need this extension called K6 client Prometheus remote, which I open here. And here we are. Yeah, it's basically an extension that allows you to use the Prometheus remote write protocol to write metrics to a remote endpoint. Mimir in this case. But you could also use it with other backend systems supporting the remote write protocol. Prometheus itself nowadays, or Cortex or Thanos. So don't think about this extension useful just for Mimir, but you can use it to test any system supporting the remote write protocol. Yeah.
We're actually, just so you know, we're actually working on a collaboration with Dynatrace as well, using this extension.
Cool.
Yeah.
Yeah, so tell us more about your script. Could you make your screen a little bit big? Could you make the
bigger,
zoom a bit higher?
Yeah, I was gonna say my eyes are old and I can't I can't read it so well.
Yeah, well, it's a fairly complex script, so I will just show you, the key parts. But basically, the idea when you load test Mimir, you want to mainly load test two things: the write path and the read path. The write path is all about writing metrics, which is here in this scenario. And the read path is about running queries. We actually have few scenarios. So there are two main types of query you can run in a Prometheus system. Range queries, which are queries over a time interval, or instant queries, like here and here, which are queries running at a specific point in time. Now, for example, Grafana dashboards typically use range queries. Rule evaluations or alert evaluations are all instant queries. So in our K6 script, we wanted to test a mix of them. Yeah, we also allow to configure the. Let me scroll it down a bit. Yeah.
I have a question before you move on from the scenario. Yeah. When you were talking about the billion active series, that's being generated by the write scenario, is that right?
Yeah, that's right.
Okay.
So the write scenarios writes the 1 billion active series, and then the range queries randomly the query scenarios, range and instant query, randomly query a subset of those 1 billion metrics for each query. And that's where we configure it. For example, here in this example, we configure the distribution of the range query, like, I don't know, the 70% of the requests are over the last 1 hour, the 27% over the last 6 hours, the 2% over the last 1 day, 0.9% over the last 3 days, 0.1% over the last week, stuff like this. We configured this distribution based on the real traffic patterns we see at Grafana Labs. So when you open your dashboards, typically the default is the default time selection is the last 1 hour. So most of the queries we see are over the last 1 hour, and then we actually see a very small percentage of queries over time periods longer than a day or so. But yeah, that was basically the idea.
Oh, sorry, I just covered up on there. Pavel is asking about the extension, if we can make it an official benchmark to test other backends. I guess like Cortex or some other Prometheus flavored backend.
Yeah, I think it's a great idea. I wouldn't just use the extension, but also the script.
The script,
this script, or a fork of this script. I mean, there's no reason, to rewrite it from scratch. Maybe you want to fork this and adapt it to your needs. But yeah, I think it's a great idea. As far as the system you're testing supports the Prometheus remote write protocol on the write path and the Prometheus API on the read path, then you can just use this script to load test it, and you can compare the performances and the latency, the success rate or failure rate of different backends.
Yeah, and unfortunately with the naming, this shouldn't be confused with there's also an XK6
Yes.
output Prometheus remote, right? Which is just for outputting K6 metrics, writing that out to Mimir. So, but yeah, so there is a little bit of confusion with those two different extensions.
Yeah, but soon that'll be part of core, so maybe you can just
Yeah,
remove that.
True. Yep,
I
the
did want
remote
to
write.
ask about the other scenario, the read scenarios. Do you remember offhand what number you got up to?
In terms of QPS,
Yes.
request per second, you mean? Yeah, the 99.9% of the load was on the write path. Typically, time series database are write heavy. You write a bunch of metrics, but then you don't query back all your metrics. You query back just a very, very small subset of metrics. Problem here is you don't know when you will need that specific subset or which specific subset you will need, right? Maybe you have Grafana dashboards you rarely open, and then you have an outage, and you need the metrics to get an insight about what's going on in your system. So we typically this kind of systems have a very high load on the write path, and pretty low or medium load on the read path. And yeah, we configured this script or the load test with K6 basically to mimic the same traffic pattern. Very heavy on the write, medium load on the read path. I think on the read path we tested around 1,000 queries per second.
That's so cool, because I feel like if anything, you're underselling how performant Mimir is, because it wasn't
Right?
just a billion active series. It was really 1 billion that got sharded to 3 billion and then got deduplicated into 1 billion. And then on top of that, there was all of this other load that was going on top of it that was querying. Yeah, it's not as much as the 1 billion, right? But that's still significant.
Not to mention the queries having to go across all these different shards. I mean, MapReduce, I would assume, is similar. Is that essentially what you were doing, sending the queries off to each different clusters or nodes to run?
Query sharding works similarly to a MapReduce system. Query sharding is one of the query acceleration technique we support in Mimir, and basically allows to distribute the execution of one single query across multiple machines. We basically split the query into smaller units that we can execute concurrently, and then we merge back the result. Which is conceptually close to the MapReduce, even if on the implementation side has not been implemented as a MapReduce in Mimir. I just wanted to mention I've also published a blog post on where is it here, on how we scaled Mimir to 1 billion active series. So all the issues we found, we have been very open saying that the day zero we started testing Mimir at 1 billion series, it was failing. I mean, we found several bottlenecks, and we found issues, and it was very interesting, thanks to K6, we have been able to load test it at such scale, and we found out issues we never thought about. Like, I don't know, we found a corruption. We found a bug which was leading to corrupted network packets between the cluster nodes. And
Was
it
this
just,
the one
it
during
was just
compact
happening
in
when
the
you were
compactor?
running Mimir at such a big scale. No, it was in the member list implementation. Basically, Mimir used the gossip protocol to communicate between nodes. And when you have a very high number of nodes in the cluster, it was leading to packets bigger than 65 kilobytes. And due to a bug in the implementation, packets got corrupted, and so the communication was failing and stuff like this. But anyway, this is just a little example of the unpredictable issues you could find when you start testing your system at pretty large scale.
Yep.
So this is the CPU utilization issue for the hash ring, right? That I think I also read the blog post.
Yeah, that's also another issue we found. At some point when we were running the test at the beginning, each replica was using nearly 2 CPU cores just to propagate changes from one replica to another one. And this led to a series of optimizations in the protocol implementation, which allowed us to shrink the CPU and memory utilization by more than the 90%. The CPU and memory utilization for the used by the member list implementation, which is the gossiping around the cluster nodes. We found bottlenecks in Prometheus TSDB, for which we have also upstreamed some improvements. If you are interested, talking about the general audience here, I invite you to check out this blog post in the Grafana Labs blog, where we give some insights about the issues we found. We link the PRs where we fixed those issues. And I think that's also, the cool part about open source, because everything is pretty much transparent. Look, here is the issue we found. Here is how we solved it. And when applicable, here is how we upstreamed the fixes or the improvements to other open source projects. Like we upstream some improvements to Prometheus TSDB or to the member list library, which is not built by us, but it's built by HashiCorp and so on.
That's cool. And now all that load testing, that was done in production, right?
Sorry?
That was done in production, right?
Nearly. Well, it was running on a production Kubernetes cluster. Yes.
Okay.
But the Mimir cluster was not a production cluster. It was a cluster dedicated for the load testing.
Right.
It was also cool to see the different kinds of tests that you must have run to find the issues that you did, because there were some that were immediately obvious. Like I know in the blog post you talk about how Prometheus uses the PromQL engine and it's single threaded. So that's something that probably was immediately a bottleneck. But there were also issues where I know there was one where you saw the write latency in the TSDB spike every 40 minutes, and I'm thinking, wow, you must have run it for hours to see that consistent spike every 40 minutes, and then to try to reproduce that, and then to try fixes, and like tell us about that. You must have needed different stages in your scenarios.
Yeah. I think the trickiest bug we found was a bug in Prometheus TSDB, which under very heavy load, system load, was basically corrupting the data. And again, we upstreamed the fix, by the way. And it took us, weeks to actually find the root cause.
Yeah.
And the main problem of this class of bugs is that they only happen when you start testing at big scale. So they are not typically reproducible on my local machine, right? So they are quite, take quite a lot of time to investigate. And the process was, a real try and error. So it was like spin up K6, reproduce the bug, stop K6, do some changes to the code base, add more logs. At some point we had, more traces and stuff like this. Deploy the new version, the new test version, rerun K6, wait until K6 breaks it, and then go on. Repeat.
We're pretty good at that.
Until you find the root cause. Unfortunately, sometimes our work is very boring.
What do you
It's
mean?
just a
This
series
is so
of
interesting.
repeating operations.
Yeah. No, but I love, and excuse me, I just wanted to note, I love the way that you said that, some of these findings were contributed back upstream, and everything. And that's one of the things that, for me personally, why I loved coming to K6 and Grafana is just the commitment to the open source community and these projects. So anyway, I heard you say that a couple times on, putting it back upstream. So just wanted to mention that before I'd forget. But yeah, it's awesome.
Well, this is like the benefit of dog fooding, right? Like we are testing
Absolutely.
because of what you did. You tested Mimir and built confidence about what it can withstand exactly. And now you have like the script that anybody can take and reproduce on their own implementation. And it's also dog fooding K6 and Prometheus. So like we can only stand to benefit from this. These are all projects that Grafana has a significant interest in, right?
Yeah. Now, did you break K6 at all? Did you have any
Yeah.
problems where that
Tell us
was
the
not
bad
doing it
stuff.
for you? Yeah.
Yeah, surprisingly not.
Aw.
I mean, it's not possible that just our software breaks, right?
Yeah.
It must be also other people's software that breaks.
Yeah. No, were there any things
I'm
that you
joking,
wish
I'm
had been
joking.
better?
Sorry?
Were there any things about K6 that you wish had been better?
We actually gave some feedback internally to K6 engineers while using it to test Mimir, especially in terms of reporting when you run K6 through the... Sorry. First of all, I want to mention we use the K6 Cloud to run this test, right? And so, we used the beautiful UI and dashboards you have. We were looking for a better reporting. For example, the feedback we got from the Prometheus remote write extension in terms of checks reported in the K6 UI was not great. But again, K6 developers have addressed our feedback very quickly.
Awesome.
So before the end of this test, we actually got all the improvements we were asking for.
That's cool.
So, yeah, my experience was really, really positive.
Yeah, and then so you were just using the K6 Cloud dashboards and everything. Did you try using the Grafana K6 app, where you could actually
that's what I was going to ask.
Yeah, from Grafana dashboards, communicating out to K6 Cloud to pull the actual data for rendering in Grafana?
No, we didn't. We used the K6 command line during the script development, running it at a very, very small scale. And then K6 Cloud to run the same script, but at a big scale. Just to give you some numbers, I think at some point we were running with 120,000 virtual users in K6.
Wow.
Nice.
Just a couple.
Just a couple. I've been told it was an expensive test.
I'm
Do you know
sure
how
that's
much?
a lot of resources.
I know, but I can't mention it.
Oh, okay.
It's a company secret.
Well, it's a test which lasted for quite a lot of time. We are talking about months, right?
was
That's the other
this
thing I want to
permanently
mention.
running?
We
for
didn't
months?
run Mimir at 1 billion active series for 1 hour. We ran it for months. We wanted to test everything, like Kubernetes cluster upgrades running while we were running Mimir at 1 billion active series, or rolling updates. We wanted to test a bunch of failure scenarios. So it takes time, obviously.
Well, it sounds like with that retention policy, it's we need to have this soak test running for a year.
Yeah, well, if you want to pay for it, I would be very happy.
Oh, so is this actually the reason why Grafana bought K6? So you wouldn't have to pay the bill. I see.
That's right.
It all makes sense now.
The dots are connecting.
No, actually, I think Grafana was using K6, and K6 people were using Grafana like since even before the acquisition. But I also like that you even tested what it would take when Mimir is in microservices mode to roll out changes to the ingesters, and you tested it with 600 ingesters. This is like above and beyond testing.
Yeah. Well, I can actually give you the number of CPU cores.
Oh wow, Powell, our CTO. He just said, I recall these tests generated about 70 to 100 terabytes of bandwidth per day for weeks. That's awesome.
Yeah. We were running the Mimir cluster with a total of 1,500 replicas, about 7,000 CPU cores, and 30 terabytes of RAM.
Wow. That's so cool that you did that.
Yeah, that's the biggest test I've ever run in my career.
Yeah, that's definitely a good test for K6 Cloud as well. So I'm sure they got some feedback from that, running that large of a volume.
I also think that the Grafana K6 app that Paul mentioned, I think it came out after you had finished your test. So that's probably why it hadn't been suggested to you. And it might have been also partly because of your feedback that it was created. But we did a K6 office hours on it a few weeks ago, and it is so much better now than at the beginning. It is so seamless. It's the aim is to recreate a K6 Cloud dashboard, but in Grafana. So it's not just a data source anymore. It's like a full-blown app. So you also, back to the issue with rolling out the change to the ingesters. I really like that in the blog that you said that you got it from 50 hours that it would have taken to update each of those ingesters because it had to be done sequentially to 30 minutes.
Yeah. So this was a limitation which came from Cortex. Well, due to how the sharding and replication model work both in Cortex and Mimir, you can't roll out two ingesters at the same time. So to guarantee high availability, you have to roll out one ingester at a time. During the ingester startup, we have to reply the write-ahead log. So think about if replaying the write-ahead log takes around 5 minutes and you have 600 ingesters, it takes more than a day to roll out all your ingesters. What we did in Mimir was introducing a way to basically roll out group ingesters together, which we call zones. Each group is called a zone. And we can roll out all the ingesters in one zone at the same time. So yeah, we deployed, and we nowadays we recommend to deploy Mimir using 3 zones, one per replication shard. And roll out all the ingesters at the same time in each zone. So yeah, rolling out ingesters goes down from more than a day to less than 30 minutes. And again, when we launched Mimir, we were already deploying running Mimir with 3 zones at Grafana Labs. So all our production clusters at Grafana Labs run with this kind of setup.
We are running out of time, unfortunately, but maybe we could answer one last question from Ayan Baduri. Do we have any article where we can remote write Mimir metrics to Grafana Cloud?
Yeah, definitely. I can. Maybe we can follow up at the end of the live stream with a link to our documentation, just because I have to find it.
Yeah, sure.
Yeah,
I can put it in the. I can put it in the comment in the in the description below in the YouTube video.
But yeah, we have a documentation on how to start writing Prometheus metrics to Grafana Cloud. And I also want to mention we have a free tier. So if you just want to give it a try, you don't have to pay for anything.
Okay, well, thank you so much for coming on. It's really cool that you're from the same company, and yet it's still like you're from a different team. So it's cool to hear about your experiences of K6, and you really put it through its paces. It wasn't just testing it out. So that was super interesting. Next week, we do have Grafana Fest, and there won't be any K6 office hours because most of us will be off in an undisclosed location enjoying ourselves. And the week after that, instead of office hours, we're going to have a community call that's going to be about the latest version of K6, which is 0.38. And that'll be with Paul here and Leandro. So I'm going to be off for 2 weeks.
Get to rest
Marco,
up.
any last words?
Yeah, thank you very much for having me here. I enjoyed a lot talking to you, and I wish to meet you in person at Grafana Fest.
Yes.
Yeah. All right. Thank you both. Yeah, and thank you to everybody who's watching. Have a good weekend. Bye.
Stay safe. Bye-bye.